Sammy from MIT, but she'll be actually calling in virtually. This is a last-minute plan we had to make because she was unable to travel at the last minute. So we'll have her talk be projected here, and we'll leave some time to do the setup to transition to a virtual talk. Okay, great. So our next speaker is Sharad Goel, who's a professor of public policy at the Harvard Kennedy School, where he studies public policy through the lens of computer science. And his work brings a computational perspective to a range of issues, social and political issues, including criminal justice, reform, democratic governance, and equitable design of algorithms. So we're very excited to have Sharad share his work with us today. Thank you so much. Yeah.
Hi, everybody. Thanks for that introduction, Lydia. So I'm going to talk about some work that's fresh off the presses. So please ask questions throughout, and I will preface this by saying I'm going to try to be somewhat provocative, and I hope you will push back and just keep this exciting. Okay, and this is done with joint work with two of my PhD students, Hans Gabler and Calvin Eisling. So as many of you probably know, there's kind of a decades-long debate on standardized tests. So think SAT, ACT, GRE. And proponents argue that standardized tests are a useful signal of academic preparation. And opponents argue that these are burdensome and biased. So this is kind of the terms of the debate. And for the most part, over the last couple decades, and you all probably took standardized tests when you were applying to schools, I would say the proponents have largely won this debate. And then, for kind of several decades, and then COVID happened. And during COVID, it was just like logistically hard to take standardized tests. And then after COVID, a lot of schools, a lot of selective schools in particular, just didn't go back to test mandated policies. Everything was there largely it was test optional. And so David Leonhardt, writing in the New York Times a couple years ago, was saying this switch to test optional reflects a backlash against standardized tests that began long before the pandemic, and many people have hailed the change as a victory for equity in higher education, right? So it was mostly test required, then it switched, and this was this backlash against this testing movement. But then there was a backlash against a backlash, and so again, Leonhardt, writing in the New York Times, he had this big piece talking about this misguided war on the SAT. And this was kind of coupled with a lot of relatively recent academic work that is finding that there's a lot of predictive power to standardized tests. And so just a couple of these quotes from this article. So this is from Leonhardt's piece. Research has increasingly shown that standardized test scores contain real information helping to predict college grades, chances of graduation, and post-college success. The word predict shows up 12 times in this article. And so it's like very much about this like idea that prediction is boosted by using test scores. One of the key plots in the research, and this is grabbed from his article, but it's pulled from academic work. This is your SAT or ACT equivalent score on the x-axis here, and on the vertical axis we see GPA, college GPA, and you see this like strong trend here where a couple hundred points on the SAT corresponds to this like relatively large boost on your GPA, and this holds even after you account for other factors. And so the article, pretty much it was summarizing the academic research reasonably well. There's been a lot of this work, especially in economics, over the last few years, that has pretty much universally found that including standardized tests boosts the predictions of things like future grades, income, opportunities, likelihood to go to graduate school. All of these things, these test scores are boosting this. But it's not, it's got a lot of tension in the last few years because these schools are oscillating between these different types of policies. But it's not a new debate, and there's been research going back decades that has basically found these same types of effects. Okay, so because of all these different pressures, this like backlash against the backlash, a lot of schools now have gone back to test mandated policy. So almost all selective schools, I think maybe all but one of the Ivies has gone back to test mandated policies. And so here, this is Dartmouth talking in 2024, Dartmouth president, informed by new research, the one that the papers I just flashed up there, Dartmouth will reactivate standardized testing requirements for undergraduate admission. And And then here, this is our Harvard Dean of Faculty in Arts and Sciences. Around the same time, Harvard also went test optional back to test mandated. Standardized tests are a means for all students, regardless of their background and life experience, to provide information that is predictive of success in college and beyond. So again, like very much this like idea bolstered by the research, bolstered by the public writing, that test scores are predictive of these outcomes that colleges care about, and so their use should be included in the admission process. So it's a straightforward argument, and it really, it feels like, the way this has been largely framed to date is that there's like this squishy notion of tests being biased and burdensome, but all the serious people think that this is predictive, and so therefore we should use this in our admissions process. So kind of that has been the back and forth over the last several decades, but really come into focus in the last few years as these decisions have been made. Okay, so I want to revisit this debate, and I want to point to two key statistical problems that really stretches the last couple decades of analysis of this work. And so the first is really much exactly on point of this workshop, is that there's a conflation between predictions and decisions. And so implicitly in these arguments, people are assuming that the predictive power translates to the decision that one should be making. And so that's kind of implicit in all of this work. And the second is this weak baselines that people are comparing against. And this is a little bit, I would say this, in some sense, this first one is an unforced error. The second one is harder because it's only in the last couple of years that we could do the type of feature extraction from unstructured data that allows us to create strong baselines. But it turns out that both of these are important in informing these types of policy choices. And so after correcting for both of these problems, we find that test scores provide little to no marginal value, at least in the setting that we're considering, which of course has immediate policy implications for the types of policies that these schools will deploy. Okay. So to make this argument, I want to first start by replicating past results. And so we're going to look at several years of applicant data from a large competitive master's program at a policy school. And I'm going to make this with graduate admissions because that's the data that we have. But you'll see that the structure of the argument is really, it translates directly to the undergraduate admissions where a lot of this debate is happening. And also I'm going to give you some theoretical results to help you kind of map between these different settings. And we're going to predict grades, at least at the beginning. We're going to predict grades for first year statistics and economics classes. That is the core at the policy program. And we're going to use two different methods of doing this. A baseline model that is just based on GPA. That's sort of the standard econometric approach. And then we're going to use the test score model that additionally includes GRE scores. And later I'm going to introduce some other models, but right now we're just going to do this kind of horse race between the GPA model and the GPA plus test score model, which is, again, the standard thing that this literature has been doing. Okay, so here, these are the results on our data. And this plot looks familiar, I think. It's like this is a version of what I flashed up a minute ago. And so again, here's GRE scores. Before it was SAT because it was undergraduate. Now this is GRE. And again, we have the grade, the GPA on the y-axis. And so here we're saying after adjusting for GPA, what is the marginal predictive power of GRE score on your first year grades in this quantitative core? And so it's very similar to what the literature has shown. And here, for example, just to give you one data point, so going from 150 to 170 on the GRE corresponds to 3.2 to a 3.5 GPA. So at the school, grades are curved in a pretty kind of serious way, and so only like 15% of students are getting A's, and so the grades are actually quite informative. That's why they're kind of lower than what you might see at other programs. And so this is like pretty big, and then you can also like quantify this in terms of the R squared. And so for the baseline model that just uses the GPA, the R squared is 0.19, and for the GPA model which uses test score, it goes up to 0.31. So these are like big. By any sort of measure of predictive performance, we're seeing like a big boost from going from a GPA-only model to a GPA plus test score model. So you look at this. So it's like everything checks out so far. It's like, there have been lots of papers written on the predictive power of test scores. It's like we replicate the result in a slightly different population. It all like kind of checks out. Like it's true that test scores provide a big predictive boost on first year grades or whatever kind of outcome you want to look at. And so that's like, it is true as far as we can tell. Now, the problem, of course, is that the predictive performance doesn't tell us a lot about the decisions or what types of decisions we should be making. And so here we want to understand, well, what is going to happen to the quality of those decisions if we were to use these two different models to inform our admissions decisions. Like you look at this and you're like, oh, it's got to be huge. Again, you look at this plot and you're like, it would be crazy not to use this information because look at this signal and it's like, it looks like there's a lot of information there, but we have to think hard about what is actually the downstream implication of using these two different models. Okay. So we're going to estimate the impact of these two models, the baseline and the baseline plus test score model. And I am going to kind of simulate situations where we admit the top 20% of applicants. But the results are qualitatively similar if we use other thresholds, and I'll show you some of those results later. But just to keep things concrete, we're going to do top 20%, which again is like pretty sort of standard in this world. So for each model, the baseline test score model, we're going to do three things, just to, again, make this very concrete. First, we're going to predict GPA with both of these two models. Then we're going to select the top 20% of applicants based on their predicted GPA. And then we're going to create the average GPA of the selected applicants as a measure of the quality of the admitted class. Right, the whole idea of using these two different models, or of using any model here, is that you want to optimize the quality of your admitted class. And so we're just going to look at what does that downstream quality look like under these two different decision rules. And the one complication is we don't have grades for people who ultimately didn't attend. Right, we know the grades for the people who attended, but we have to do something for the people who didn't attend. So we're going to do three different things. So the simplest is we just infer the grades for applicants who didn't attend. So we have like a big pool of applicants, like 20,000 applicants, and we can just infer what would their grades be had they been admitted and they ultimately attended the program, and then we can just run the simulation and we can see what happens. The second is my worry is, well, some of those folks are really out of distribution. So you're trying to do this inference for these people. It's like that's not going to work very well, and so we can restrict ourselves using some kind of overlap condition and say, at least let's not take the entire applicant pool. Let's only look at applicants who have a 10% chance of being admitted historically. And so for those folks, they're like pretty much in the distribution. So we feel like we can make reasonable inferences about those folks. And then the final thing is we can restrict to the people, we restrict to the matriculants themselves. So these are the people who are admitted and attended. And so here we directly observe the grades. And now, we're going to take 20% of those people. So it's like a very competitive pool at that point. But these are just kind of three different ways that we can try to get around the problem of not seeing the outcomes for everybody. Ultimately, all these lead to the same results. And so again, for simplicity, I'm only going to show you the results for the first one, but all of these are give us the same qualitative results. Please, Emma. Exactly. So everything is held out. Please, Deb.
Do you have access to a waiting list, perhaps? Is it possible that you could have looked at waitlisted folks that might not have otherwise attended and looked at their application?
Yeah, there's not really a wait list at the institution. Yeah, it's a good question. Please, in the back.
So you're not concerned about unmeasurables in terms of who attends or who matriculates?
Yeah, so there's sort of two senses in which you might care about unobservables. The first is that it worsens your predictions. That is by design not something that we are concerned with, because the whole goal of this is just construct reasonable predictive models. And so one model is the baseline model, just GPA, and the other model is GPA plus test score. So that's literally, that is a horse race that people want to run, and so that is a horse race that we're running. The other sense is the unobservables that might affect the outcomes, the grades. And there, it's like if you're really, really concerned about it, you can just look at number 3. These are the people for whom you observe it. So you're not estimating anything. They're just saying, those are the people. It's like, over these 20 years, a few thousand people actually attended the institution. Now let's select from those people and see what would the composition of that class look like, but we're not doing any inference. So here there's nothing. But it turns out, there is something funny about going to the matriculants. I mean, they're just like a little bit different. And so in theory, it doesn't have to be the same result as these first two. In practice, it turns out to be the same. But again, in theory, you're absolutely right that there could be a mismatch there. Please, and then,
If the grades are being, I mean, I guess it doesn't matter for the first one necessarily, but if you said that the grades are set so that only 15% of people get A's, so there's this restriction based on the pool, how does that interact with
Yeah, so it's a good question. So we use the grades. Basically, the grades are like a quality measure of the person. There's not, but we're not saying, if all of these people were admitted by the curve, only 15% of them are going to get A's. So that is not the thing we're estimating. We're estimating is like, you hold the rest of the class the same, you put them in there, and now what it is. But you're exactly right. So the grades are a good signal, but of course, if we admitted a stronger class, then those like A students would not be getting Bs. But that's sort of a separate thing. Yeah, Nikhil, please.
The inference depends on a predictive model, but then you have to choose the variables. There seems something circular.
Yeah. So okay. I mean, again, I'm kind of glossing over some of the details here, but we use a much more sophisticated predictive model for the inference. And this is using essentially the entire application, much more than test scores and grades. And I'm going to show you a complex model in a minute, but we have reasonably high confidence that we can predict this well. But again, even if you don't believe that, just think about this. And it turns out that even like not even qualitatively, but quantitatively, they're basically the same result. But I just wanted to be transparent about how it is that we're doing this inference. Please.
How do you estimate the probability of attending?
Again, just like we're fitting historical models. Yeah.
So based on their application data?
Exactly, yeah. Yeah, Emma.
What if you didn't want to just maximize GPA?
Yeah.
You want to look at like,
It's a great
impact on
yeah.
people's lives, et cetera? Like,
Yeah, so that's a great question. So everything here, I'm trying to stack the deck in favor of the proponents of using test scores. You're exactly right that it turns out at the school that that the grade, the academic performance or academic potential is one of 4 different components. And if you run this entire analysis on the utility that we infer from the data or from the previous admissions data, everything shrinks. And so, as you would expect, because here I am saying it's like, let's play by the game that people are saying. It's like, I only care about academic performance. I'm going to admit people exactly on that. But now let's say I care about, public service. Well, the academic performance gap just doesn't matter as much. Everything is going to shrink. And so these are, in some sense, like the best case for the proponents of test scores. Please.
For the baseline model to make sense, are you restricting the applicant pool to those people that went to an undergraduate institution with a 4-point GPA scale?
No, we convert everything.
You convert. So if you have like a 10-point GPA scale, you rescale?
Yeah, so there's a sophisticated mapping between like what different scales mean in different countries, but they're kind of external services that help with this mapping. So very much, especially in policy schools, half of applicants are not from the US, so this is like a common problem that comes up. And again, even if this were a concern, this is exactly the motivation for the proponents of GREs. They're saying it's like, what do GPAs mean? They mean nothing. It's like, here, like at Harvard, the average GPA is 3.8 or something like that. It's like something obscenely high. And now in some other country, there's actual differentiation. And now you're just like, you're just like putting everything together. So this is exactly the argument that people are saying. It's like we need a common, unified, ungameable system for determining who is the the good applicant. Again, that's the argument that people make. Okay, so the baseline GPA model using this method of top 20% is 3.54, and if you use this plus the test score model, again, this is like there's high predictive boost from using it, but if you apply it in this decision theoretic framework, it goes up to 3.59. Okay, so this is about a 0.05 move in the average GPA, and so you can think about that as a half letter grade improvement for 10% of students. And so this is like pretty modest. It's not nothing, but it's pretty modest, and I would say it is not the type of effect that people would be imagining it when they're sort of writing these papers and writing these kind of public pieces about how it's so important to be considering test scores when you're making these types of decisions. I think this is basically the type of year-to-year variability that we see in applicant pool is kind of on the order of these different changes. Okay, but So first of all, why is this happening? It's like you look at this, you're like, well, how can it both be the case that these scores have high predictive value and then also have relatively small benefit in terms of the quality of the downstream decisions? And it's like very kind of obvious, at least in retrospect, answer for what is going on is that you have a plot like this where this is the, for everybody, these are their predicted GPA. This is the entire applicant pool. You have some threshold. We're doing like top K, so these are the top 20% of the applicant pool. And in theory, you should take all of the people to the right of this threshold, like under your best model, the GPA plus test score model. In practice, you get, under the baseline model, you get some of these people, and you also get some of the people on the other side of the threshold. And so what is going on? Well, the people who are clearly like strong applicants are going to get in regardless of what that model is. If it's GPA or if it's GPA per test score, you're going to get in. And you see that here. It's like all these, like the strongest applicants get in regardless of what the model is. So now near the threshold, you have people who are on the bubble. Some of them get in, some of them don't. But it doesn't change that much. And so essentially, it's like people who are clearly going to be accepted, or like clearly strong, they get in. People who are not going to succeed in the core classes will not get in, regardless of what model you use. And so the only place where there's ambiguity are people who are on that threshold. But again, the whole point of being close to the threshold is that they're pretty similar. And so it doesn't much matter exactly who you choose around that threshold in terms of the quality of the class. Please, Emma. Yeah, it's a good question. It's about 25% or so. Yeah. And so these are different people. So that's like an appreciable difference. Now the thing is, in terms of the quality of those applicants, it is at least measured by GPA, they're kind of the same. But this is kind of a great point of like, I'm going to come back to this in a minute. It's like you are changing the composition of class in an important way, and I'm going to show you how that matters. But at least in terms of the quality of the academic quality of the class, it's all roughly the same. So again, you can formalize this a bit, and it's like so you do it, you see it, it's sort of very intuitive. You can formalize it and just say it's like we have two predictors of some outcome. And so the outcome is just the observed outcome is the GPA. We have two predictors. We have our baseline predictor and we have our comprehensive predictor. And so now we can exactly compute what this change is on a couple other things. I'm going to walk through this. So the first is this is the difference in the average GPA of admitted students on their two models. And so here they're saying conditional on being above some threshold under one model. What is your expected GPA? We do that for the two models. We look at the difference. That's the thing that was 0.05. And now we're going to have the standard deviation of the GPA in the applicable. That's just the scaling parameter to set the scale of the problem. This is the interesting thing here. This is the difference in the predictive quality between the two models. And so here, this is a correlation. So this is the R and the R squared. And so we can just look at that difference. That's something we can estimate from data. But also what's interesting is we can estimate this in other kind of papers and literature without having access to the data that makes the predictions. It's just like tells us what those correlations look like. And then finally, we just have a fixed factor that depends on the threshold. So in our case of 20%, this turns out to be 2. But it's just like a fixed problem independent number. So it's very straightforward how you can do this. This is the entirety of it. This is the entire theoretical statement. But the intuition is clear about what is happening. It's like you have these things. It's like they're a little bit fuzzy, but the fuzziness only depends on how well these predictors are matching the outcome. And in practice, you can't have really big, even if you have really big gaps in the predictive quality or what we think of as big gaps, they actually can't lead to big differences in the quality of the class. Yeah, Hannah, please. How the gap changes with respect to?
So are there if we were admitting more of the class versus less of the people?
So this is it. This is exactly what it tells us. And so here, this is a theoretical the gap as a function of the threshold. So if we have a more selective, like 5% of the class versus 20% of the class, then the gap is expected to go up. And here is this is in our empirical data, what we see. Like the theorem itself knows very little about the data other than these like basic correlations of the model performance and just like, very simple summary statistics of the data. And what's interesting is the theoretical model, despite its simplicity, basically matches what we find empirically. So this again gives us some confidence that this is what is happening. But to Hannah's question, even if we go to a really extreme situation of like 5%, then we still don't see these huge gaps here. And this is already, I'll say, this is a competitive program, and so it's already like a quite strong pool even before you impose something like a 5% threshold. Okay, so now I've talked about one very specific notion of class composition, which is the academic quality of the class, and that is to be fair, that is the terms of the debate, where people are arguing that it's the composition of the class largely, the academic performance of the class, which is the thing that we have to use these GRE scores for. But another part of this debate is that there is something that feels fair about using test scores over things like GPA. Or sometimes people say like letters or essays, and you're like, oh yeah, that's like, only people from privileged backgrounds are going to be able to do well in those other dimensions. And so there's something like deeply unfair about using those things as opposed to test scores, which is supposed to be this kind of, largely unbiased. Again, this is controversial, but it's like, this like unbiased measure of academic potential. And so this is the Harvard dean who's talking about this, a standardized test, or it means for all students, regardless of their background and life experience, to provide information that is predictive of success in college and beyond, and again, implicit in a way that grades and essays and letters of recommendation and you did some volunteer experience and wherever, and it's like because you had lots of money and were able to do this in ways that somebody with less advantages could do. Okay, so we looked at this, and we looked at where the people are coming from under these two different policies, a composition of the class under these two different policies. One is GPA and one is GPA plus test score. And these are the rankings of the institutions. These are global rankings, so 1 to 5, so 1 being the most competitive. So places like Berkeley are going to be up here, and then places that are sort of large competitive state schools are going to be somewhere in the middle, and then you're going to have smaller colleges on the right hand or on the left hand. And what you notice here is there's like a huge gap. So if you look at the top of the distributions, the most selective institutions, then we find that without GREs, you're mostly going to be taking people from these super selective institutions, and with GREs, you really shift that distribution down to the left, to the less competitive places. And why does that make sense? If I know that somebody has a 4.0 at a place like Berkeley, that's a strong signal that they're going to be successful in this type of, these types of courses. If I know that somebody has a 4.0 in a college where is just like much less competitive, then maybe they'll do well, but on average, they're probably going to do worse. And again, this like very much plays to the proponents of test scores. It's like in line with that intuition that in the absence of test scores, there's a limit to what you can demonstrate as your potential. That's kind of just like the door is closed once you go to college. It's like once you're there, there's just like, that's it. It's like there's a ceiling for how much potential you can show there just because of the nature of that institution. And I think that's a fair critique, and I want to come back to that in a minute. So here, past analyses have used these GPA-only models as a baseline. In reality, there's a lot of application information that is available, including letters of recommendation, detailed transcripts, work history, all of this stuff that has largely not been considered. And it's not considered, the application or the admissions committee really pays a lot of attention to all these materials, but it's been hard technically to extract that information until relatively recently. And so now kind of modern document parsing, computer vision, LLMs makes it more or less trivial to get all this information out. And so we're going to use all of this structured information to create features to improve the prediction of our baseline models. And so we're again going to take our comprehensive model that uses everything except for test scores, And then we're going to use the comprehensive model, really using everything, including test scores. So this is the horse race that we're now running. We're augmenting everything with all of these rich features that we extract from the application. And then we're going to add GRE scores on top of that. And we do that. The first thing we notice is that now the gap shrinks from about 0.05 to about 0.03, so not like a huge difference. So now it's about 10% of students are getting a third of a grade boost. That's one way to think of it. But the gap does shrink a little bit when we use all this information. But really, what's interesting about using all the information, now we get rid of this problem of only selecting students from the very competitive selective schools. And so now at this point, it really is that the people who are admitting even look very, very similar to the people who we are not admitting, whether or not we use GRE scores or not using GRE scores. They're very kind of similar populations at this point, which was different from when we're just using our baseline GPA model plus, compared to GPA plus test score model. So so now it really does feel like we're extracting all the information that was in test scores from using all the detailed transcript data, all the letters of recommendation, all of the other kind of work history and things that go into the application. Okay, so we find that, like in summary, these test scores are really boosting the predictions of academic preparation in line with all the past work in this area. But the quality of decisions doesn't really improve when you use these two things. And this problem of conflating predictions with decisions is a common, I think, consequential error. I'll give you this quote from the president of Dartmouth. SATs and ACTs can be especially helpful in identifying students from less resourced backgrounds who would succeed at Dartmouth. The test scores are an important predictor of student success in Dartmouth's curriculum. So half of this statement is true, right? So it is true that test scores are an important predictor of success, but it's not true that they're helpful in identifying the people who are going to be successful. This very subtle distinction between prediction and decision, again, the theme of this workshop, that has really been, I would say, the statistical error has really informed our test policies across the country because of thinking that predictive quality automatically boosts decision quality. In medicine, we're seeing a very similar debate play out here using whether we use race in these risk assessments. And so here, with proponents arguing that race is just like a strong predictor, what we're finding is that race is a strong predictor, but in fact, it generally leads to relatively little marginal utility, exactly for the same reason that I talked about previously, in that for most people, the decision is the same. And for the people for whom it's different, they're on the bubble. And so it didn't matter so much in terms of your utility what decision was made for them. And so exactly the same argument that we're giving earlier. And so now the question that I'll end with, and I admit that I don't really know the answer, is what should we do? Should we use test scores in admissions, or for example, race in medical risk assessment? And I'll say it depends. Test scores do improve decisions a little bit. And so if there's no cost to using it, then just use it, right? If you really think there's no cost, logistical, financial, social cost to using it, things are a little bit better. But if you do think that there is a cost, and many people believe that there is a cost to using test scores in admissions or race in medicine, then it might not be worth it. And so again, I actually personally don't have a strong opinion about whether or not we should be using test scores in admissions, but I at least want to highlight what I think the right statistical question is to be focusing on when we're making these policy choices. Thanks.
Yeah, thank you so much. So we can start setting up for the next speaker while we can take several questions because the setup will take some time. So.
You're going to shift it down the distribution because now if somebody has that 4.0 at a smaller college and you're like, oh, well, on average, they might just do okay, but you also see they have a 170 quant.